on your test the most. Okay, so let me go ahead and show you which section it is, and that's 8.4. I don't care about significant digits. This ain't science. All right. We went over these the other day, and we talked about the Pythagorean theorem. We talked about sine, cosine, and tangent. We talked about, well, we haven't talked about that yet, but we talked about finding different angles, talked about putting the man at A, putting the man at B, subtracting from 180 degrees to find the other angle, or putting your man down here and doing the inverse sine, or however, different ways to do it. We talked about that whatever day y'all came last week. What's today? Tuesday, so last Thursday. Last Thursday we talked all about that. That's basically 8.3. I don't know if, yeah, we covered all of this. Make sure you can find both sides. Once you find this side, once you find the sine, you can find this side right here. And then you can find, using the Pythagorean theorem, you can find all three sides. So, you know, let me just go, we'll go ahead and do this one just for giggles. Where's current slide? Slideshow, current slide. There we go. So draw this one out and use what we got the other, use what we did the other day. I gotta bring my whiteboard up. And fill in. I don't ask for just one thing. I tell you to do everything. Find A, B, and C. Let me pull up my whiteboard. Hold on. Pull up my whiteboard. Where's my whiteboard? Okay, it's here. So how am I going to do this? It won't let me bring up my whiteboard. Okay, there we go. There we go. Now, current slide. Okay, they give me a little whiteboard that I can use. I hope it works. Can y'all see that? Okay, because if y'all can see it, and I can see it on my monitor, then it's recording. Okay, I guess I'm going to use black. All right, so we got a triangle. That was 90 degrees. And we know that ABC with A, so I'm just going to pick A. I'm going to say A is right here. And most of the time, chances are this is going to be A, but you have to look at it. 30 degrees, this more looks like a 45-degree angle, but the lower the degree, the more it's going to be on the bottom. Okay? So A is equal to 34 degrees, 30 minutes. Now you can automatically find C if you wanted to, or B, or whatever you want to call this one. Now, if you give this one A, and you give this one B, then what's this one? C. So that means this side is C. This battery's going dead. Well, evidently somebody's been playing with it. I'm not used to this. Okay, there we go. A is 3430. And B and C, and that's little c, and that's little a, and that's little b. Okay, that's how you assign your sides. Okay? So, if I want to find angle B, I can do it several different ways, but what's the easiest way? 90 plus 3430 and subtract that from what? Okay, so that's going to be 180 minus 90 minus 34 is going to be 56, 55, 30. Somebody check me. Of course it is. And then equals, and that'll be 180 minus 55. Well, 55 from 80 is going to be what? 23 or 25? So 2430, 12430, something like that. 13430. Somebody check it.
Why would it be 55? You added our 34.
I'm sorry, I went the wrong way. I was subtracting. Don't get the wrong one. What?
You can't believe in what you're doing.
I know, I suck. I subtracted, I was thinking of that subtraction right there, I'm sorry. 90 plus 34 is 12430. How about that? Does that sound better?
Right.
Alright, minus 12430. And 12430 subtracting from that is going to be 60 or 50, what I said a while ago. What is it?
56.
56? No, 5530. Y'all check it. So, angle B is 5530. Now, how many different ways can you find these sides now? There's about 9 different ways. There's all kind of ways you can find it. So, what you do is put your little man on one of the spots. So, I'm going to put my little man right here. So, he's got his leg on the adjacent and the hypotenuse. All right, Oscar had a hump, so that's the sine, a cosine, right? So cosine of theta is equal to Oscar had, a hump, so that'd be A over H. And did they give us a side? They didn't give us a side, did they? Yes, C. Okay, they did give us. I just looked at that. So cosine of 3430 is equal to A over 12.7. So, take your handy dandy calculator and multiply both sides by 12.7. So 12.7 times cosine of 3430 is equal to A. And somebody do that in your handy dandy calculator. And what do you get? Yeah, sometime today. I'll tell you right now, if you've got a scientific calculator lying around the house that looks like a TI-30, grab it. Because the TI sucks. The TI-84 sucks as far as doing these. If you've got a little TI-80 that has a TI-30 or something that has the degrees, minutes, and seconds on the keyboard, get it. Grab it.
I got 10.47.
10.47. Why is that wrong? Why is it wrong?
It's not degrees.
Wait a minute.
It's
There, it is right. 12.7. So A is equal to 10.47. I thought you were giving me the hypotenuse. Sorry. 10.47. Now, how can you find angle A or side A? How can you find that? Using what theorem? Pythagorean theorem. So take 12.7 in your calculator, square it, and subtract 10.47, square it, and then take the square root of that number and tell me what you get. So 12.7 squared minus 10.47 squared, and then take the square root of that, and what does that give us?
16.46.
16.46. Yeah, because the hypotenuse, so you've done something wrong. The hypotenuse is longest side. That's good that you caught that. Good. So what is it? I think you probably hit the square root, the square key instead of the square root key.
Not the square root, but I didn't put everything in this, that's probably not
Russians have to farm.
I don't got this.
It can't be because you're taking away from the highest number. Let me get my handy dandy calculator out. What?
Oh, never mind.
I'm sorry, what?
It is 7.1.
That's feasible. Anybody else got 7.19?
I see. I got 51.1.
You're a loser. 7.19.
It's because we were doing not particular that episode.
7.19, is that what you got? That seems reasonable. Now, take 7.19, square it, and add it to 10.47, square it, and see if you get, and take the square root and see if you get 12.7.
Yeah, I got 7.2.
Okay. Now, this type question right here, when you're doing these on homework for 8.4, I would suggest do about 13,000 of them. You know, similar question, similar question, similar question. Because this is all about this chapter right here, chapter 8. If you can do these and fill out everything, then you're good to go. Now, get them right. You got to get them right. And hit similar question. I would do many of these if I was you. So they got 5530. Where is my? And they did all that and got 7.19. And then they probably used the Pythagorean to find B, where we found A, or the adjacent, and we used the Pythagorean to find A. I mean the opposite. So, and that's what, no, they use cosine. So you can use the sine or you can use the cosine. You can use both or you can use the Pythagorean. Some people like to use the Pythagorean because they're used to using it in high school. That's why a lot of people use the Pythagorean. You can use either one. Capiche? All right, try that one. I'm going to let y'all draw it and give y'all 4 minutes. The handouts. Don't the handouts say Skype for business? Yes or no? I need to know because I'm writing it. I thought it said Skype for business. I hate repeating myself. When y'all did the office portal, you use your T number? I mean, Well, your password, your username and password. So, solve right triangle ABC if A is 2943 and C is 50 blah, 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 blah. So, they don't tell you that if A is the hypotenuse or not. So if they don't tell you that A is the hypotenuse, then you assume that, I'm just going to say it's the adjacent, 2943. Then that means that this angle up here is angle what? Big A. Okay? You know that angle C is 5358. I'm sorry. That side C is 5358. So side C, it could be the hypotenuse. They should give you more information than this. I'm going to assume that this is angle B right there, and this is angle C. Therefore, this is little side C, which is equal to 5358. Now, I really don't like this question because it's kind of vague. You know why I'm saying it's vague? It doesn't actually tell you where the angles are. The only thing it tells you is solve right triangle ABC. So I'm going with the ABC. I'm going, since they don't designate whether 2943 or 5358 is the hypotenuse, I'm assuming that's the legs. Okay? Now, I'm going to hit enter because I really, okay? I disagree with this because how, somebody tell me where they say that angle C is the right angle. They assume that you're just going to draw it the right way. Well, I thought about that. I don't like this question. I will not give you one like this on the test because they don't give you enough information there. So we'll just erase mine and go with this one. That is not a good question. Solve right triangle ABC. Even if you read the question, solve right triangle ABC, which this is B. Either which way you go. A, B, C or A, B, C, it's going to be B. So this is not a good question. But as far as the mechanics after you draw this out, it's a good question. This is not worded correctly. Okay? They should say C is equal to the hypotenuse. They should say something like that. Or they should put parentheses hypotenuse right after. So go ahead and fill out all the information. Give me angle A, angle B, and little side B. It's amazing to me. Now, there's several different combinations that you can do. One thing, I'm going to find angle B first. So B, how many times do I have to hit it? B is going to be equal to the square root of C squared minus A squared. B squared, B is equal to the square root of 5358 squared minus 2943 squared. Now somebody do this in your calculator. And B,
44.77.
say again,
44.77.
everybody get that? So there's B. Now I could have done that, but that's putting your little man down on A down there. So you could have done that. So however you want to do it, I don't really care. Now I'm going to find angle A. So take your point, which one you want. You got your adjacent. A is equal to 44.77. O is equal to this, and H is equal to this. So take your pick on which trigonometric function. Since sine comes first, we'll do sine. Sine of theta is equal to Oscar had, so 2943 over 5358. Theta is equal to the inverse sine, since we're divided by sine on both sides. Bring this up, becomes -1 of 29 over 53. And somebody give me that angle. (29.43) divided by 53.58, and then take the inverse sine. Make sure you're in degree mode. 33.31. Everybody get that?
Yeah.
And that one's 33.31. And since we're in decimal, I'm not worried about it. And this one is going to be 180 minus 90 plus 33.31. Or, if you don't want to use that, you could do sine of theta equals, this changes to, that changes to the opposite, and this changes to the adjacent. So sine is equal to Oscar had, so 44.7, so 44 ... over 53 ... And somebody take the inverse sine of 44.7 over 53.58 and tell me what you get. Well, that's 123.31. So that's going to be 56.69. Somebody help me out. 56.69. Now, I didn't do the trig in my head, I did the math in my head. But you get the same answer. Okay? Now, some people say, well, why don't you just take that away from 90? Well, you could. You could take 33.31 away from 90 if you wanted to. Okay? It's however you want to do it, because you know that those two angles make up 90 and the three angles make up 180. So if you want to subtract it from 180, you can. If you want to just subtract the one angle from 90, you can do that too. It's the same thing. Now, besides the question being vague, this is still a good question. Okay? I would not put this on the test. If I put this on the test and you got it wrong, I would probably give you, because there is nothing there unless I'm missing something. To me, okay, I see one indicator, and that's this. That's the only indicator I see. In all of your trig, what is always the hypotenuse? C. Is that very good on a test? No, I would not do that on a test. I would not just say, okay, well, just remember C is always the hypotenuse. No. That's the only indicator I see right there. So I should have took that into respect when I was looking at it, but to me that's a contradiction with that. I'm sorry. It's either A, B, C, or A, B, C. You can say what you want to. Just make sure you can do the math right, okay? If I see one like that on the test, I will try to fix it. But if you see one like this on the test, just take into account that C is going to be the hypotenuse. And like you said, it's the longest side. So both of those are still vague. That's too vague for me. All right, I'll shut up. And they got 56.68. I guess we got that. I don't know. And they got 44.7. Did we get that? Yes, Hubert. No, Hubert. We're not going to talk to you, Hubert. Okay. Did we get 44.7?
Yes.
Thank you. Thank you for the interaction. It makes class go by a whole lot faster. All right, you need to make a note of this because students get this messed up. All right. What have we been talking about this whole time? We've been talking about horizontal angles. All right. Now, what the heck is a horizontal angle? A horizontal angle is you standing in the room, in the middle of the room, and looking 360 degrees around the room. Everybody with me? That's a horizontal angle. A vertical angle is looking up or looking what? Down. That is a vertical angle. Now, in geometry, there's also a vertical angle when one angle is on top of the other. So there's really two meanings of a vertical angle. Also, angle of elevation, that's called a vertical angle. Or a vertical angle is called angle of elevation. All right? It's always going to be between 0 and 90. Why between 0 and 90? Because you're not going to look at a point on this wall and flip your head over and look at this wall. All right? Your line of sight is from here to here. So a vertical or an elevation angle is up from 0 to 90. 0 to negative 90 is your deflection. And that's what that is right there, or depression. Angle of depression. These are usually elevation angles. Now, when do you use an elevation angle? When you're trying to find the height of something like a tree, and you don't want to climb the tree, or you know the angle to the tip of the tree. Water tank, we've done that before, surveying before. When you want to find the angle, you just have to get a distance to the transit, to the center of the bottom of the water tank, and then take a shot to the top of the water tank, and you know the vertical angle. Once you've got your vertical angle and your bottom distance, you can tell what the height of the water tank is. All right? So that's what these are. And chances are they're going to give you an example. Draw a sketch. Have y'all heard that before? There we go. Think of a water tank right here. Now, take what you know and see if you can't do it. Because there's nothing new. The only thing new is you're not turning a horizontal angle. You're turning a vertical angle. You're looking how high something is or how low something is. And I want you to find everything. I want you to find all the angles and all the distances. Because if you can find all the angles and all the distances, then you're good to go for the test. I had steak and green beans today and a avocado for lunch. It's pretty good. No, Hubert, I had lunch today. I had pizza for lunch. I had a sandwich. Huh? Breakfast changes. You know, I didn't know all these semesters, I didn't know PowerPoint had a inside whiteboard. I think I'll start making my own PowerPoints now. I don't really like PowerPoint though. But I think in some classes it's needed. In Trig, it's needed. Because everything is, if you don't do it in a certain way, it all kind of goes what? Runs together. So I'm going to take my handy dandy pen and I'm going to put my little man right here. So A is equal to 37.62. Therefore, this is the opposite. First of all, this would never happen in the real world. Why? Why would you not know? How is the only way you would know the height of that building? You're gonna measure. How you gonna measure? Somebody gonna climb up the side of it? Okay, building plan. That's the only way you would know how tall the building is. Now, or you're surveying a piece of property, are you gonna have the building plans to that building? Not if it's on the property adjoining you, and you didn't pull the plans. So chances are this is not real world. Why? Because nobody would know the height of that building except for the owner or the plans. Or you got out there and you actually shot or dropped a measuring tape down to measure the building. So I just bring out that usually this is not the way it's done. The way it's done is you usually turn a vertical angle and you can actually just shoot to the top. So I just thought I'd tell you that. So you can find this angle, this side, by Pythagorean theorem. Square root of 34 ... squared plus 37 ... squared. And somebody give me that distance. 50.768. Okay, y'all check it, make sure that's get a second on that. Now we can find any angle we want. Now, since I'm standing right here, I'm going to use the sign. No, you don't have to use the sign, you can use whatever you want. Oscar had 34 over 50. 34.09 over 50.768. And theta is equal to the inverse sine of 34.09 over 50.768. And somebody tell me what that comes out to be. All right, I'm just going to say 42 degrees. So what's the other angle? Angle 48 degrees. So this angle right here is 48 degrees. And this one is 42 degrees. See how simple trig is? It's simple. This
So
As long as you got a calculator, you're good. Hmm?
which one is the elevation of the sun?
Which one is the what?
Elevation of the sun.
I didn't even notice that. I thought they were asking for, oh well. Draw you a line. Now that is real world, okay? We can do that. Take the elevation of the sun, that's that angle, because it's using the angle right here. So you're basically setting yourself up for what? A new triangle. Okay? I didn't even read that, I'm sorry. You know, this angle is 48. If this angle is 48, then this angle is 48 by geometry, and this is 42. So you've got two angles. Well, actually, you got three angles, and you've got a distance. Where's the distance? Oh, okay. We don't have a distance. We got. Let's see. There must be something I'm looking at. The length of the shadow of a building, 34 meters tall, is 37. So this is 34 meters tall. Okay, similar triangles. Draw a picture of two triangles. That's what you're going to have to do. Draw a picture of two triangles. When you do that, we already figured the angle. I'm sorry. Find the elevation. Okay, that is wrong. Okay. The elevation what? The elevation angle. Okay, the elevation is what? That's that side right there. This is elevation. Okay, that's where academia and the real world collide. Elevation is not correct. It's the elevation angle.
So we found that.
We already found it. It's 42 degrees. I'm sorry, I was trying to find the elevation of the sun based on the... Now, you could do it with a similar triangle, but you would have to know one distance. You would have to know either this distance, or you would have to know what? This distance. Well, you're not going to know this distance, because if you could get this distance, then you got the technology to get this distance. Yeah, you really couldn't. You would have to get 90. You'd have to get 90 degrees to the sun, which is just about impossible to do unless you were at the center of the earth. So, whoever wrote these questions really sucks. Okay, I'm gonna be honest with you. That first question was vague, and this second question was, the reason I didn't catch it is I didn't even see this. I thought they were just wanting you to fill out the angles and the distances. Kind of helps to read the directions, Hubert. Sorry about that. Yeah, they just left out. Find the elevation. Now, if anybody asks you what the elevation is, you automatically think of the height of something. You don't think of the elevation angle. That's supposed to be angle. Okay, shut up, Hubert. Okay, bearings. All right. Bearings is off of north. Remember that. Actually, that's wrong. Zenith angles are off of north. But in this application, bearings are off of north. Bearings can be off of north and they can be off of south. All right? But we're not going to worry about this is actually showing you a zenith angle, not a bearing, but we'll get to that in just a few minutes. So let's look at this one. Radar stations A and B on an east-west line. East-west means a straight line horizontal. East-west line. Of A, east-west with A west of B. Okay, so start at A, go west of B. Or B west, go this way. Okay? 3.7 kilometers apart. Station A detects a plane on a bearing of 61 degrees. Okay? Now again, that bearing is technically wrong. It's supposed to be a zenith angle or a zenith. The reason I'm telling you that is because if you're on a bearing, what do they give you besides the angle on a bearing? Direction. What do they call? North, northwest, south, southeast. You remember here, you ever seen a bearing with south and east on it in your books, in your math books before? That's a bearing. A zenith is off of one directional plate, and that is the north. That's why a zenith does not have a bearing on it. A zenith does not have southwest. A zenith does not have northeast. It doesn't have anything like that. It has just 50 degrees. 50 degrees, that's in the northeast quadrant, because 50 degrees is right there, off of north. But if you call it a bearing, it's 50 degrees northeast. So that's the difference. So you might want to make a note of that. Anyway, on a zenith of 61 degrees. Zenith of 61 degrees. Okay? See, they even doing it wrong here. They're calling it, that should be a zenith of 331 degrees. Because they're showing 331 degrees. This is totally wrong. This right here is not correct. Station B simultaneously detects the, okay, I'm sorry, I'm reading the wrong side. I'm not wrong. Station B simultaneously detects the same plane. This is Station B, dork. Station B is 331. Find the distance from A to C. Well, you know this angle is 61 degrees, therefore this angle is what? Because of what? Starts with a C. Complementary angles. This one, you know that this one is 61 degrees. How? There's two reasons you know this one's 61 degrees. Name one reason. Subtract it from 180 or 90. That's one reason. What's the other reason? Geometry. Alternate exterior angles or alternate interior angles, whichever one you're looking at. If this one is 61 degrees, then this one right here is going to be 61 degrees. But I like the Pythagorean theorem because you never doubt the Pythagorean theorem unless you just can't add. All right, now draw this picture right here in your notebook paper and read the directions because I don't read the directions very well. Find the distance from A to C. A to C. I'd say find both distances if I was you. And again, you got to worry about where your man is. So I'm going to put my little man right here. So he's got one line on the adjacent and one line on the what? And one on the hypotenuse. Now the reason this is flipped is because the hypotenuse is always across from the 90-degree angle. Always. Okay, so Oscar had a hunk. So a hunk is cosine. Cosine of theta is equal to a hunk. So cosine of 29 degrees is equal to A over 3.7. Multiply both sides times 3.7. And somebody tell me what 3.7 times cosine of 29 is.
3.23.
3.23. Now you can use the Pythagorean theorem and say 3.7 squared, or whatever side you want to call this B. B is equal to 3.7 squared minus 3.23 squared, and take the square root of that. Somebody tell me what B is. .7 squared, that's, well, that'd be 4 squared, basically. 4 squared is 16. 16 minus 9. Hold on a minute. 16 minus 9 is 5. Square root of 5 is 2.7. So I'd say around 3 maybe, or no, it'd be 2.7 or 2.8. What'd y'all get? Okay, I'm waiting. No, 9 and 16 is 7. The square root of 7 is 3.2. So it'd be around 3.2. What is it? Is it 1.8? Well, I'm doing it wrong.
Well, you aren't doing this with that, like this 3.2 was as a not.
Yeah. 16 minus 9 is what? 7? Square root of 7 is around 3.2, I thought.
3.7 squared minus 3.23 squared was 3.2.
Well, I was just using estimation, but I guess it might work. What'd you get, 1.8?
Yeah.
I don't know either. I bet they'll take my medicine today, I don't know. 3.23. Now hopefully if I read the directions correctly, which I haven't been doing real good today. Will you see this on the test? You'll see problems like this on the test, but not this one. Capiche? All right, draw a sketch. Well, since a line drawn due north is perpendicular to the east-west line, which is true, right angles are formed at A and B. Yeah? Oh, this is how you do it. I'm sorry. This is correct. Okay? This is a correct statement. That first one was not correct. Where they said the bearing was coming off the north, though that's called a zenith. This is correct. 42 degrees northeast, 31 degrees southeast, 40 degrees southwest, 52 degrees northwest. That is correct. The bearing from A to C is 52 degrees east. A, C. Now that's coming off of south. Okay, you can't say coming off the north, it's coming off the south, because a bearing comes off the north or south line, depending on what direction is on. So, the bearing from A to C is 52 degrees. A to C. And you just draw a line. Just draw a line and put a dot on the end of it and say C. The bearing from A to B, right here, is 84 degrees northeast. So that's coming off almost 90 degrees. And you draw a line this way and put a dot. The bearing from B to C, is 38 degrees southwest. And then you connect the dots. Okay, now that's all the directions. So you just kind of wipe this out, wipe everything out from here up after you draw a picture. There, that's the directions.
Where does it get the C for 600 miles from? It doesn't give us that.
I don't know. By multiplying this times this. A plane flying at 250 miles per hour takes 2.4 hours to go from A to B. So if it takes you an hour to get from here to Charlotte, how long will it take you to get back? Another hour. All right? So now you got a picture. So now you can actually do the math. Now, how did they find this 44 degrees?
By 100.
No. Actually, they got that 44 degrees from, they would have to subtract it here and here. Let's see, this is 90 degrees coming through here. Oops, that's not good. Hold on a second. How do I go back? Can I go back? Nope. Oops. Hold on. I don't have the capability of drawing a straight line on this thing. So from here to here is 90 degrees from here to here. Let me draw this on. No, I don't want to draw it on here because it's already messed up. All right, just draw the picture. And they give you 600. The only thing they really give you is 600. They give you this one right here. And once you get it drawn out, draw a straight line, straight 90 degrees off of north from A to this other side right here, right there. It'll be straight across, right there. You draw it like this. Make sure you draw it 90 degrees, so it would help to have a credit card or something to draw it off of 90 degrees. Now we know that the angle right here is 6 degrees. How do we know that? That's how I'm going to start teaching. I'm just going to mumble words. How do we know that this angle right here is 6 degrees? Well, this red line represents what? 90 degrees. So what's this right here? 6 degrees. How did I get that 6 degrees? I'm asking y'all, that's not rhetorical.
No.
Okay, this line right here, this line right here represents 90 degrees off of north. 90 degrees off of north is what? East. So there's the east line right there. If that's 90 degrees east, and this blue line is 84 degrees northeast, then what is this little area right here? 6 degrees. How did I get to 6 degrees? 90 minus 84. Okay. If this represents 90 degrees, then I subtract 52 from 90 degrees, what do I get? 40 what? 38. Well, yeah, whatever. 38. So what's 38 plus 6? That's not rhetorical. 44. It'd be nice to be able to draw my straight edge on this thing but this is north, this is south, the 90 degrees would be east. Now there's another way to get it. Take this angle. Take this angle plus this angle and subtract it from what? 180. So take 180 minus 84 plus 52. You can do it that way. That should come up to 44. Same thing over here. 180 minus parentheses 96 plus what? 38. Now, somebody tell me what you get here. Well, 80, that's 6. 6, and I can't add 8s very well. 136. 136 from 180 is 44. 96 plus 38 is what? 134. And what's 134 from 180? 46. Now, the way that you get this is draw a picture. Okay? If you don't, that's why in stats, not stat, in statics, and I've been through statics and dynamics. When you go through statics and dynamics, you better know how to draw pictures out of your trig, calc, and what other class? Physics. If you haven't learned how to draw a free body diagram after you've taken these classes, you can forget about these classes. Because you have got to learn. Now, for that person that said, oh, I don't have to draw, I'll just do it in my head. You're going to fail here, you're going to fail here, you're going to fail here, and you're going to fail here. If you're one of those people that, go ahead, I'll see you in the soup line. All right? Question. So, now that you've got these angles, you can start with your actual drawing. So, I got a drawing now. I don't like to read it. So now I've got a 90 degrees, this is 44, and this is 46, and this is 600. So I'm just going to go ahead and find both sides because I really don't care what they're asking for. As y'all can tell, I mess up the question. I'm going to put my man right here, and that's looking at the adjacent right here and the opposite. So whatever you want to do, sine of 44 degrees equals Oscar had the O over 600. So multiply both sides by 600. 600 times the sine of 44 is equal to O. And what is 600 times the sine of 44? 431 point what? And that's equal to the opposite. Now you can use Pythagorean theorem, or we can use cosine, a hump. Cosine of 44 degrees is equal to A over 600.
Wait, I did cosine, not sine, so that's the wrong number. That's the cosine.
So this is 431.6 is equal to A. And somebody give me this one. What's the sine of 44 times 600? So 417 feet, 432 feet. So which one did we find? We find 416 or 432 feet. Is that the one A to C? Yeah. 432 feet. What did they get?
They did sign, they did.
Still should get the same answer. Sine of 46, they went on the other side, you still should get the same answer.
It still comes up to minus 131.6.
Something's not right. Even if you did, they put their man right here. Put your man right here. Then he's got his foot on the hypotenuse and the adjacent. And he's looking at the opposite. So if you want to find the opposite, that's the one we want to find, then the sine, that'd be the cosine of 46 degrees, or the Oscar had no, it's sine. Sine of 46 degrees. Sine of 46 degrees is equal to Oscar O over 600. Yeah, they're wrong. 431.6, is that what we got before?
Yep.
Okay, they're wrong, unless they want you to
Like round down.
round down. I don't think I would round down. I guess I don't know. I guess since they're just rounding to the nearest 100, maybe right here, I guess that's what they're wanting everybody to do. I don't know.
Well, no, because they still go 430.
Yeah. It'd be 400 if they were doing that. So, okay, you see what I'm having to deal with here, so just bear with me.
It's 20 after 12.
Okay, thank you. I gotta get out of here because they'll knock down the door. Okay, we'll continue with 8.4 when we get through. We still got probably 3 or 4 more things to do. So we're gonna call it a day today. Let me shut down the Skype. See y'all. Just work on 8.1 through 8.3. You can work on a couple of 8.4 if you want to, but we're not finished with 8.4, so you're not required